will now compute resistance in series and resistance in parallel. So first, remember the formula delta V is equal to IR. So we start out by drawing resistance in series. So you have the battery, delta V is the potential difference, then you have two resistances R1 and R2. And you have current I flowing through them. So R1 is here, R2 is here. So current I is flowing through both R1 and R2. But the potential difference across these two batteries could be different. So across R1 potential difference is delta V1 and across R2 potential difference is delta V2. So the total potential is still the potential provided by the battery. So delta V is equal to delta V1 plus delta V2. Now you multiply both sides by I, you get I times delta V is equal to I times delta V1 plus I times delta V2. So I times delta V is the equivalent resistance which we have just calculated, and I times delta V1 is R1 and I times delta V2 is R2. So we have just calculated the equivalent resistance. So these two resistors can be combined into a single resistor, which we denote by R subscript EQ, means R equivalent. So you have reduced two resistors to one resistor by the formula R1 plus R2. Now you can extend this to n number of resistors which are connected in series. Now notice that for resistance in series, current through both the resistors is the same. So from both the resistors, I is passing through, but potential difference across these two resistors could be different. So current through both the resistors is the same, but potential difference is different. So now we talk about resistance in parallel. So you have two resistances which are connected in parallel. So let us draw this. You have the battery here, and then you have two resistance in parallel. So we need to reduce the circuit to equivalent resistance. So you have delta V here, positive and negative side, resistance R1 and R2, and you have current flowing through them. Now the current splits into two different branches, I1 and I2, but the potential difference across R1 and R2 is delta V because they are connected in parallel. So potential across these resistors is the same, but current through them is different. So total current will remain the same. I is equal to I1 plus I2. Now I is equal to delta V by R. So replace I by delta V by R equivalent, and I1 would be delta V by R1 and I2 is delta V by R2. So I2 is current flowing through R2, I1 is current flowing through R1. You cancel out delta V. You get the equivalent resistance. 1 over equivalent resistance is equal to 1 by R1 plus 1 by R2. So this is the equivalent resistance for two resistance connected in parallel. So you can, instead of the circuit in parallel, you could draw a simple circuit like this, and this R equivalent is equal to the two resistance which have been connected in parallel. So this circuit is same as this circuit in terms of resistance. So we can extend this formula to n resistors connected in parallel also. So in that case, 1 by R equivalent would be equal to 1 by R1 plus 1 by R2 plus 1 by R3 plus 1 by R4 and so on. So let us do an example now. So in this example, we need to calculate the equivalent resistance of the circuit. So this is how the circuit is given to you. So you have some resistance here. Then you have two connected in parallel here. So we are just drawing the circuit, then we will label the resistance, and then we will find out the equivalent resistance of this circuit. So say this is 4 ohms, there is 6 ohm, 2 ohms, 1 ohm, 3 ohm and 8 ohms. So we need to find the equivalent resistance of this circuit. So first consider this parallel circuit. So 1 by R will be equal to 1 by 1 plus 1 by 3. So this is nothing but 4 by 3. So R will be equal to 3 by 4. Now consider this parallel circuit containing 6 and 2. You get 1 by R is equal to 1 by 6 plus 1 by 2. So this will be equal to 4 by 6. This implies R is equal to 6 by 4, or you can say 3 by 2. So let us redraw the circuit now. So we keep 4 ohms as such, and here you get 3 by 2 ohms. The next resistance next to 4 ohms becomes 3 by 4 ohms, and here you get 8 ohms as such, and this is the circuit. Now you have resistance in series, so you can add it up. So 4 plus 3 by 4, this will give you 19 by 4, and 3 by 2 plus 8 will also give you 19 by 4. So now we will redraw the circuit again. So now we are having only two resistance and they are in parallel. So you have 19 by 4 here and 19 by 4 here. So this is 19 by 4 and this is 19 by 4. So now you say 1 by R is equal to, the total resistance 1 by R is equal to 1 by 19 by 4 plus 1 by 19 by 4. So you add this up, you will get 8 by 19. So R is equal to 19 by 8. So you can reduce this entire circuit to a single resistance, this equivalent resistance of 19 by 8 ohms.